I'm Joris Hiddema, the engineering manager for Challenger Forst. And Challenger is a company which is under the umbrella of AGCO, and AGCO is a global company for agricultural machineries. And AGCO is the mother brand for Fendt, Massey Ferguson, Valtra, GSI and Challenger. And Challenger is the high-spec machinery for AGCO for sprayer equipment, tractors, the more specialized products. A sprayer in general is maybe the most important machinery equipment for a farmer, because that depends how healthy his crop is. That is the machine where he can protect the crop with, and he is doing that by spreading chemicals or liquid fertilizer over the field, and he wants to do that as precisely as possible. But of course he has also to take care for the environment, and he also has to try to has his costs under control. So what is very important for a customer is that he is spreading his chemicals and his liquid fertilizer as equal as possible and there where it is needed. And for that reason it is very important that he is driving with the booms over the field, that the booms are as stable as possible in every direction. So the horizontal direction, the vertical direction, everything should be under control. And for that reason we developed a complete new boom and boom suspension, and that was where Siemens PLM was involved and was helping us to develop that. So we started in 2008 to develop a complete new product for the Western and Central European market, and we started completely from scratch. So we developed everything again and everything to develop such a product based on what the customer demand was at that time. So the challenging thing was we started from scratch, so everything was new. That gave us at that time a huge opportunity, but it was of course also a big risk. And for that reason we were looking for partners who could help us by developing certain components and certain parts of the machine. And one of our partners, which still was at that time LMS, which is now Siemens PLM. So we used LMS virtual motion, we used LMS FEA calculation program, and we also did the correlation between what is happening in the field and what is happening on the computer screen. We did some shaker tests where LMS was using all their sensor technology for it. We did a kind of hammer test to look for the frequencies, try to find a correlation between our calculations and what was happening there. And at the end that was resulting in a variation coefficient that is basically an explanation for how good the boom is distributing his chemicals over the field, which was on such a level that we can compete with the best, and maybe we are in the best on that area. And if you are working on an engineering department, most of the time you only hear the things which were not going well, and you very hardly hear what is going well. Since we launched this machine, we don't hear anything about boom suspension, or we heard a comment that the boom suspension is very, very good. So this again proves that working together with LMS was the right direction. At the end of the day, the result is actually where you are looking for, and if the result is showing that working together and using knowledge from several areas, that is where you are looking for, and if that is a success, then you are proving that a project has gone right.